Hey guys, welcome back to my channel. Today we're going to do transformations. We're going to do transformation of shapes, which includes translation, enlargement, rotation, and reflection. So let's start with the first question. It says that describe fully the single transformation that maps triangle A onto triangle B. So we have to figure out what is the single transformation that maps triangle A onto triangle B. As you can see, the size of the shape has changed. So whenever the size changes, it's a clear indication that's an enlargement. So for enlargement, what we need is the scale factor and the center of enlargement. So over here, if we highlight two corresponding lengths, let's say this one and this one, we can see that this length increases by 3, which means the scale factor for this enlargement is 3. So we write enlargement. That's the first mark. By scale factor of 3. That's the second mark. And now the center. Now for the center of enlargement, what we will do is you will connect corresponding points. So this is corresponding to this. This point is corresponding to this. And this one is corresponding to this one. So we connect them with straight lines. And the point where all of these straight lines intersect, that is going to be your center of enlargement. So as you can see, that point is 3, 0. So we will say enlargement by scale factor of 3 about the center 3, 0. That's your answer. So main thing you need to remember that in enlargement, the size of the shape would obviously change. And secondly, to figure out the center of enlargement, you would connect corresponding points through straight lines like I did. And the point at which all of those lines are intersecting, that's your center of enlargement. And for the scale factor, then what you will do is the new image that we have, you divide its length by the original image. And that over here is 3 and over here it's 1. So 3 divided by 1 is 3. So scale factor is 3. Then it says on the grid above, translate triangle A by scale by the vector -4, 3. Label your triangle C. So let's remove this. So we're translating triangle A by the vector -4 and 3. So when it says translate, that means we're either moving the shape up or down or left or right, depending on what the translation vector is. So the number at the top, that's your X value, and the number at the bottom, that's your Y value. So if the top number is negative, then we move the shape to the left side. If the top number is positive, we move the shape to the right side. Similarly, if the bottom number is negative, we move the shape down. And if it's positive, we move the shape up. Here, since X is negative, that means you'll move the shape to the left-hand side. So if you pick one point over here, this one, this is 5 over here. So 5 will move 4 units to the left, which means it's going to come at 1. Then it's 3 units up. So if it's at 1 over here for Y, 3 units up is going to be at 4. So this is where the point will come. So let me remove this. Similarly, if I pick this point, so move this 4 units to the left. So it comes at 2. And then 3 units up, that's over here. And then the third point is going to come over here. 4 units to the left and 3 up. So now this is your triangle C. That's how you translate. So to summarize, in a translation vector, the top number is the X value and the bottom number is the Y value. If the top number is negative, you move the shape to the left. If it's positive, you move the shape to the right. If the bottom number is negative, we move the shape down. If it's positive, we move the shape up. That's translation and enlargement. Then the next question says, on the grid, rotate triangle A 180 degrees about the center 1, -1, and label the new triangle B. So previously we did enlargement and translation. Now we're going to do rotation. So first we need to mark our center of rotation, which is 1, -1. So 1, -1, that's over here. And now we're rotating this 180 degrees. So for this, you need to remember that if this is your original shape, if you would move this shape 90 degrees, it's going to look like this. And if we move this 180 degrees, it's going to look like this. So first thing is for you to establish what the shape would look like what would be the direction of the shape. So this is 90-degree rotation and this is 180. Now, once you've established the direction, now we need to find the coordinates at which the shape will be placed. So let me remove this part. So let's find the position of this point first. So this point is 2 horizontally, 2 vertically. So the image would also be 2 horizontally and 2 vertically. So that's over here. Similarly, for this point, that's 4 horizontally, 2 vertically. So we go 1, 2, 3, 4 horizontally, 2 vertically. That's over here. And then the last one, that's 2 horizontally, 3 vertically. So we go 2 horizontally and 3 vertically. So this is how we would find the position of our 180-degree rotation for the given triangle. As you can see, the direction is the same as what we initially decided. And for the placement of the coordinates, you need to remember that in 180-degree rotation, your horizontal and vertical distance of the points from the center, they do not change. It remains the same. What is changing is the direction of the shape. So like we said, if this is 2 horizontally, this is 2 horizontally. If this is 2 vertically, it will be 2 vertically. The same horizontal and vertical distance of each coordinate from the center when it comes to a 180-degree rotation. Then it's saying on the grid, translate triangle A by the vector -7 and 3. So like we did in the previous part, the top number is X and the bottom number is Y. In this case, the translation vector is pretty much the same. The X value is negative and the Y value is positive. So we move 7 units to the left. So A, let's pick the purple point. So if you pick the purple point, it's going 7 to the left. So 1, 2, 3, 4, 5, 6, 7, and 3 up. So 1, 2, 3. This is where it comes. Then the pink point, 7 to the left. So 5, 6, 7, and 3 up. And this one is at 3, 2. So again, 7 to the left and 3 up. So as you can see the translation, the size does not change. The direction of the shape does not change. The only thing that changes is where the shape is placed. So this is your triangle C. So that was rotation and translation in the same question. In this question says, on the grid, enlarge the shaded shape with scale factor 1/3 and center 1, 7. So first, let's mark the center, which is 1, 7. That's over here. Next, what I'm going to do is I'm going to mark lengths on the given shape. So we have this length over here, and then we have this length over here. Now this vertical length is 9 because we're starting from 4 and ending at 13. So 13 minus 4 is 9. And this horizontal length is 13 minus 7, which is 6. Now to find the lengths of the new image after the enlargement, we will multiply the lengths of the given image with the scale factor. So 9 times 1/3 is going to be 3. And 6 times 1/3 is going to be 2. Which means for the enlargement, the new image will have a horizontal distance of 2 and a vertical distance of 3. Now, to identify the exact placement of this triangle, we will look at the placement of the coordinates. of the given triangle from the center. Now this point is 6 units horizontally and 3 vertically. So we know 6 divided by 3 is 2. So now the new image will be 2 horizontally and 3 divided by 3 is 1. So 1 vertically, which means it's going to be over here. 2 units horizontally, 1 unit vertically. Similarly, this one is 6 units now. So we know 6 divided by 3 is 2, which means this point will come over here. For this one, it's 9. So 9 divided by 3 is 3. So that's going to be over here. And if you compare its position from the center, it's 1, 2, 3, 4, 5, 6 units vertically and 6 horizontally. So that's 2 horizontally and 2 vertically because 6 divided by 3 is 2. Now we just connect these points. And this is our enlarged triangle. We can check if this triangle is correct or not by connecting corresponding points and see if they pass through the center or not. So this, and this one. So we can clearly see that this is our enlarged triangle. Scale factor was 1/3 and center is 1/7. Then this one says on the grid above, reflect the shape A in the line y equals to x. So reflection like very rarely comes, but I'm glad they gave it. This is from the 2025 paper. So we're going to first draw the line y equals to x. Y equals to x is a line where all of the x and y values are same. So if you notice when x is 1, y is 1, when x is 2, y is 2, and so on. So this is our y equals to x line. Now we have to reflect the shape in this line. So when reflecting the shape, what we need to see is that the image has to be at the same distance from the line as the original shape is. So if you pick this point, for example, this point is 1 whole block and half. So again, half and 1 whole. So this is where it will come. Then for this point, that's 1 whole and half. So again, half and 1 whole. Then for this one, it's 1, 2, 3. So 1, 2, 3. And lastly, for this one, that's 1, 2. So 1, 2. So we're just going in the same line across y equals to x, and we're counting the same number of boxes so that it's an exact mirror image. So now we connect the points, and this is your reflection, the line y equals to x. Then the next question says the diagram shows a sketch of triangle A and triangle B on a coordinate grid. Given that the triangle A has been translated to give triangle B, we have to work out the value of D, E, and F. So we need to see what is the translation vector first. So let's use the points that are already given for the same corresponding point. So triangle A is becoming triangle B. So -7 goes to +6 and 2 goes to 12. So that means over here, we're adding 13 because we're going from -7 to +6. And over here, going from 2 to 12. So we're adding 10. So the vector is 13, 10. So now let's pick the other point. So if I pick this point, -11 becomes 2. So we added 30. That's correct. And for D, we're going to do -5 plus 10, and that's 5. So D is 5. Then for this one, F, -3, and 9e. So now we're going backwards to find F. So we will do 9 minus 13, which is -4. So F is -4. And for E, we will do -3 plus 10, because when we go from A to B, for the Y value, we're adding 10. So that's going to be 7. So 5, 7, -4. These are your values of P, E, and F. Then for the next question says the diagram shows shape P and shape Q drawn on a grid. Describe fully the single transformation that maps shape P onto shape Q. So once again, this is the same as the first question that we did. So we have to identify what sort of transformation is happening. Since the size of the shape has changed, it clearly means it's an enlargement. And for the enlargement, we need the scale factor and the center of enlargement. So first, let's highlight corresponding lengths and see how they have changed. So let's pick these two. So this one is 2, and this one is 1, 2, 3, 4, 5, 6. So enlargement by the scale factor of 3, because 2 becomes 6. Now we need to find the center. So about the center. Now for the center coordinates, I told you we connect corresponding points using a straight line. And the point through which all the lines are passing, that is your center of enlargement. So as you can see, the center of enlargement is this 0, 2. Then it says on the grid above, rotate shape P 90 degrees clockwise about the center 3, 5. Label your shape R. So let's remove this. 3, 5 is over here. So we have to rotate shape P 90 degrees clockwise. 90 degree clockwise is going to be in this direction. So our shape is going to look like this. So now when you're rotating a shape 90 degrees clockwise, what we do is we swap the horizontal and vertical distance for each point. So basically what I mean is that if I pick a point over here, let's say this point. So this point is 1 unit vertically. So this point is 1 unit horizontally from the center. So that means the image will be 1 unit vertically now. So it's going to come over here. This orange point is 2 units vertically from the center. Now it's going to be 2 horizontal from the center. So that means it's going to come over here. Then, so this one is 1 horizontal, 2 vertical. So now it's going to be 2 horizontal, 1 vertical. So over here. And the last point, this is 3 vertical. Now it's going to be 3 horizontal. So this is your image. And this is called R. So to summarize, when you're rotating an object 90 degrees clockwise or anti-clockwise, what you do is you swap the horizontal and vertical distance from the center for the original shape for the new image. So if the horizontal distance is 1, so now it's going to be vertical distance 1. So that's what you do for the 90-degree rotation. And for the 180-degree rotation, your horizontal and vertical distance remains the same. What changes is the direction of the image. So that's how you differentiate between a 180-degree rotation and a 90-degree rotation. And with that, we're done with the transformation questions. If there's still any confusion about any of these transformations, please leave a comment below and I'll try to help you out. And if you're someone new to the channel, please like and subscribe and follow this playlist for in-depth exam questions for each topic for IGCSE Edexcel Maths Higher.